No, Peter's not here. Peter, everyone's mad at you because you're not here. All right, the number of computers sold at electronic stores each day of a week is shown in the dot plot. So, what percent of all computers, Alexandra and Uali, do I need to stop my video? Thank you. Uh, what percent of all computers sold during the entire week were sold on Friday? Well, we look at the entire week, Monday through Sunday, and then we look on Friday. How many did we sell on Friday? 12, right? Out of a total of what? 40. There were 50, right? 50 that were sold on the whole week. So to find that, we do our little P over W percentage. We don't know the percentage. That's our X. And then we notice out of 100. Then we know that we sold 12 out of 50 on Friday, right? We cross multiply, we get 50x and 1200. We divide by 50, and we get 40. What do we get? What? 220. 2400. Are you sure? 5 goes 2, and then we get, I think it's 225. And it says round. Yeah, no, we get 24. Okay, this looks a mess though. It's 24 for that one. So we can say that 24% of the computers were sold on Friday. If you don't have 24, put an X on it. What percent of computers were sold on weekdays? Wait, what percent of computers sold on weekdays were sold on Tuesday? What are we looking at? Only weekdays, right? So we can make a line right here and say we are not including Saturday and Sunday. We're only including the weekdays, Monday through Friday, right? And if we take away Saturday and Sunday, we end up with a total of 40, right? And now we look at the ones that we sold on Tuesday. How many were there? It seems like your brains are about 2 seconds behind the processing level. What processes speed? So we do the same thing. P over W with the percentage. We don't know the percentage, but we know it's out of 100. For the sold on Tuesday, we know it was 9 out of 40, right? When you cross multiply and divide, did I do this right? Yeah. 40x equals 900. We divide by 40, x equals 22.5. But it says round to the nearest percent. So we round this to 23%. There we go. That's not too crazy, is it? The next question. Suppose the data described above for the electronic store were represented with a bar graph instead of a dot plot. So it will look kind of like this instead. Bar, 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 oh no, bar, and bar. And then obviously whenever you do bars, you shade. So you can't see the dots, but... So tell me, what are the advantages of having a bar graph? What about it is easier? How? Yes, it's easy to spot the biggest and the smallest. Uh, the numbers we have to kind of estimate because we don't have a y-axis. We only have that. So, but we will have to have a y-axis, right? To tell us where the numbers meet. What would be a disadvantage? Look at it. Yes. Oh, there you go. You can't count it, right? You have no dots. You have to go and rely on whatever the line says on the side. So if you put any of those, it's correct. If you put something random, no. All right, the next one. The time zones, the number of states in the United States are primarily in each of the time zones is shown in the bar graph. Before I start, I like to put numbers on my stuff so I know what I'm talking about. So this is 4. This must be 7 because it's more than half of that, and that goes by fours. This is probably 1. This is 21, and this is 16, and this is 1 again. So if you remember your history right, the continental U.S. has how many states? Continental, meaning in altogether, 48, right? And they have Hawaii and Alaska, which are outside. It's like, what? I'm going to go and talk to Mr. Cawthorn about this. So the continental United States is all states except Hawaii and Alaska. So we don't include Hawaii or Alaska on a continental U.S. Alaska is way up there. Hawaii is way out there in the water. They're not all together. What percent of the continental states? Continental states. What am I talking about here? Only the ones are together, right? So these 4, not Hawaii, not Alaska. What percent out of those are primarily Eastern? What do you do? Crickets. I hope you did it. P over W, okay. That's a good start. So we have percent here. We don't know the percentage, so we know 100. And then for the states, what are we going to put on top? Why do you put 21 on top? That's how much we have Eastern, right? And what do we put at the bottom? 48, right? The total of the Eastern, Central, Mountain, Pacific. We cannot use 50 because we're not including Alaska or Hawaii. So when you do P over W, you get 48x equals 2100 divided by 48. You get 43, right? I think. Where'd it go? 43.75. 43.75% according to my calculations. Ta-da. It doesn't ask you to round, so I will leave it that way. Yes. Do what? 45% would not be the accurate way of rounding either. If you put 44%, I will take that. If you put 43.8%, I'll take that. If you put anything else, no. Because that means you're not running correctly. Okay. But for future reference, do not round unless you're told to for this kind of stuff. All right. Is the percent of the continental states primarily in the Eastern time zone greater? So is this guy over here greater or less than the percent of all states in the mountain or central zone? What do you do? Subtract. What do we subtract? P over W with what? See, this is when you start guessing. I need you not to guess. Subtract, multiply, divide. That's not good. That's what you're going to do on a test, too. That's scary. So we don't know the percentage, right? What are we going to use for the states? Both? It says or. That means not combined, but either or. Are any of those less than or greater than? So I would just go with the bigger one, right? So 16 out of how many? 50 because it says all states. You're comparing it to all states. So when you cross multiply and divide, you get 50x equals 1600 divided by 50. X equals, did I do it? No. I thought I did it. Where'd it go? Okay, I guess not. So you divide it, and where's my phone? Ain't got time for that. Wah. I'm not the one testing, it's you. Bam. 32. Try using the calculator, you get a 0. So it'll be 32% for Central Time, which is the biggest one. So which one's bigger? The one on top, right? So basically, the eastern time zones, even without Alaska and Hawaii, is still larger than central when you include all the states. And it's definitely larger than the mountain, right? Mine's a lot smaller. All right, suppose the horizontal scale of the bar graph had intervals of 1 instead of 4, meaning that it had lines like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 blah. Suppose you have that. Would there be any advantages to that? What would it be? I'll translate what he said. It would be more accurate. That means you have a line going right through the things, and you would be able to see that this is actually 1 because it's going all the way along the line. And you'll be able to see that this is actually 7 because it's going right on the line. Well, my pen is not exactly accurate right now. But that would be one of the advantages. What is the disadvantage? It'd be longer. What else? Disadvantage. Disadvantage. Perhaps too many lines, right? Too many lines, and it gets confusing sometimes to follow that. All right, next page. All the boys attending a prom wore a tuxedo. The circle graph shows the number of boys wearing each of the different bow tie colors. As you can see, black is generally the most common color whenever you wear a tuxedo. Estimate the percent of the boys wearing black bow ties by comparing the black section of the graph to the whole graph. When they say estimate, they don't want you to calculate. Just give you a number. So what I would do here, because I'm cool like that, I would just divide this in half. And notice that 66 is actually more than a quarter, right? So I would say it's about 30-some percent, 30+%. If you put exactly 33, that means you calculated it. No, it's not wrong, but I didn't want you to calculate. I want you to estimate. It's to have a what? So where does that matter? Let's keep it that way and go to 11, and we might be able to understand why that is. So calculate the percent of boys wearing each bow tie color. We're gonna do P over W. I'm gonna do it over here. And percent 60. That's not percentages, right? That's people. That's bow ties. So I don't know the percentage. I know it's out of 100, and I know that 66 people were black bow ties out of 200, right? Total. When you add them all up, it gives you 200. So you cross multiply and divide, you get 200. X equals 6600. When you divide by 200, cross, you get X equals 33, right? So 33% of the people were black bow ties. What can you tell me between this and this right here, the 66? It's double, right? Well, can you infer that or generalize that maybe all the values should be cut in half and it will give you the percentage? How can you prove that? Not necessarily, just by looking at it. How can you tell me quickly, without having to do any calculations, prove to me that it'll work? That would be another one, yes. That's another answer, yeah. What else? It's going to be a little uneven if you do it that way. By adding. I want you to look at this. And tell me what 33% is written as a fraction. Over what? Isn't this just a simplification of this guy? So if you can say if 66 is out of 200, then 33 out of 100 should give me the percentage. That's it. I can put every value over 200 and simplify it to the percentage. So 25 over 200 simplified will give me 12.5 out of 100, which is 12.5%, right? So for gray, we will get 12.5%. For white, what do we get? 24%, yes. Cut them in half. For blue, what do you get? 11%. For red, what do you get? 9%. For green, what do you get? 6.5%. And for purple, you get 4%. These are very simple, right? Basically, what you're doing is generalizing. You're using the same idea for everything else in there. And it works because they're all out of 200. Blah, 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 blah. We're not going to go over those so I can get to the other part. All right, so we're going to move on to our next part, which is comparing information, comparing data. So you can use dot plots to analyze data set, especially with respect to the center, meaning what's in the middle, or the spread, how it's spread out across the graph. People once used body parts for measurement. For example, an inch was the width of a man's thumb. In the 12th century, King Henry I of England stated that a yard was the distance from his nose to his outstretched arm's thumb. The dot plot shows the different lengths in inches of the yards for students in the 7th grade class. So people like you guys. Aren't you in 7th grade? So what's the about? All right. Describe the shape of the dot plot. Are the dots evenly distributed or grouped on one side? What do you think? Are they all grouped on one side or they're evenly distributed? They look fairly evenly distributed, right? They're not all grouped onto the 28s or onto the 35s. They pretty much spread out pretty good, right? Describe the center of the dot plot. What single dot would be the best to represent the data? What do you think? What single number out of there you think would be the best one to represent the data? 31, maybe? 31 and a half, it's right in the middle, right? 31 and a half is right between the ones that are less than and greater than. It's like the midpoint almost. All right, describe the spread of the dot plot. Are there any outliers? Outliers, what are outliers? The what? That was good. No, outliers are not in the middle. Outliers is literally almost like what it sounds as outside. They're not exactly with the rest of the team. They're just like out there. So these guys will be considered outliers right here. Maybe that one too. Because they're not close to the rest of the other guys, right? Or the 28 and the 35 out there. Those are like people with, I guess, larger length of arm. All right. Blah, blah, blah. I'm going to do that one. So this is the other part. So the dot plots show the heights of 15 high school basketball players and the heights of 15 high school softball players. Notice that the graphs are color-coded, so you can see the difference. One of them is for the softball, the other one's for basketball. So all the data is, when they ask you for the shape, they're asking you where the data is mainly. So this guy said the data is 5'6" or less for the basketball. Is that true? It is. The other one says, that one says all the data. For basketball, it says most of, not everything, but most of the data is from 5'8" and higher, right? It seems like these are exceptional people. Does that make sense that those people were kind of exceptional, like not really part of it? Why? Huh? Why do you think that those people are not exactly part of the whole? What? I can't hear. They're shorter, right? And we're talking about basketball. Most people who play basketball are tall, right? So when you have people who are shorter, those are the outliers. Kind of like a video. He's shorter when you compare to the other kids who play basketball. He's good though, but he just happens to be a kid who's smaller than the rest of them. So when you put him on a chart like that, you will be able to see, oh, that's him. No one. As a group, the softball players are shorter than the basketball players. That it makes sense. The softball players are like under 5'6", and the basketball players are mainly above 5'8". So the next one, visually compare the center of the plot. The data is centered around 5'4". Does that make sense for the softball? Maybe not, but if we eliminate from each side to get to it, we might end up at that point. Yep. If we spread it all out, we end up with the midpoint at 5'4". And then the center around 5'8" for this one. Do the same thing. Yep. 5'8". This means that the most common height for the softball players in feet is 5 feet and 4 inches. Oh, that was a different kind of idea. So they were talking about the center. Where do you have the most of? Well, you have the most of 5'4", right? For that one. You have the most of 5'8" for that one. Okay. That was stupid. Okay. Compare the spread to the dot plots. What is the spread? What do they mean by spread? Yeah, make it flat, how far apart they are, right? From the biggest one to the smallest one. So yeah, it shows you that 411, which is right here, is the shorter distance, well, the shortest height, and then 5'6" is the tallest for the softball players. For this one, be 5'2" and 6. Notice though that I'm not counting these lines to tell me that. I'm counting the dots. We're looking at the dots, not the lines in the middle, not the numbers at the bottom, but the dots. That's what they're talking where they are. All right. So after using that information, answer the questions on your turn right here, basically using the same criteria. What is the shape, meaning where's the data mainly? What is the center? Which one has the most of? And then what is the spread? What is the entire range, basically? On your own. Let's go. Okay, so what is the shape of it? What? What was your answer to ask you what is the shape? Yes. Yeah, most are greater than 5'2", right? 5'2" or greater. Good job. What is the center, Madison? 5'3"? There's nothing on 5'3". I would say 5'2", right? Again, we're talking about the dots, not the lines at the bottom, not the numbers. There are more dots at 5'2", right? So I would also call that the center, because that's where most of them meet. What is spread? 411 to what? To 5'6". And again, we're focusing on the dots that we have, not the lines. We don't care about the lines. The lines are just there to give you an idea of where they land. Good. All right, comparing plots numerically. Numerically compare the plots of the numbers of hours a class of students exercises each week to the number of hours they play video games each week. This is very interesting, and it's actually, you can use this as a real information. Notice how each week there are students who get 0 exercise. That means they don't have PE in school, and they basically go home and like play games or don't do anything. They probably don't even walk up as much. And then you have most people who are around here, right? Around 2.5 hours of exercise that they get or below. Then you have these crazy people who get what? Then we have these people over here who exercise 12 hours per week. Does that sound crazy? You need to come back for your homework. I'm serious. You need it. Do what? I'll be gone by 4:45. This guy, who you snap his fingers at? Please excuse Tabaria. Okay, so we will look at those. There are 2 people who actually exercise 12 hours a week. Does that make sense? Soccer player, somebody who plays sports. You could say that if they have practice at least once a day. Sometimes after school you practice 2 hours a day, right? After school, that'll be at least 10 hours. And if you have a game the weekend, that's 12 hours. That makes sense. But we don't have any kids who play sports and exercise that much. You only have two in this situation. Yes. Good. And then we have two who are in the middle. These are probably the average kids who have PE every day. You have an hour of exercise every day, and then on the weekends, let's say that you go and just play with your friends, and that's some kind of exercise. Uh, that's basically what we look at. That's how you analyze information, and that's how you relate it to your own ideas. I don't want you to learn this just because you have to. I want you to be able to see this and say, man, is that true? Can I find myself in those dots? And I promise you that all of you can find yourself somewhere on that line of the amount of exercise you do. Uh, Look at the contrary for video games. I have one kid over here whose parents are a little more responsible and say, no, you're not playing video games. We're going to have you doing more stuff. You're going to do something that is productive. Or some kid who just doesn't care for video games. I really don't care. There's some kids who don't like them at all. So that could be that one kid who does not play video games on the phones or on the TV. Or you just simply don't have the time. Then you have all these kids over here who play at least 6 hours per week. That is a lot of video games per week. And then you have this guy over here who spends 14 hours a week playing video games. Do you see any connection between the two? What can you tell me about those two? I'm saying between the two, what are the connections? Do you see anything? Between the people who play video games and the people who who don't exercise or exercise? So basically, yes, more hours playing video games and less on exercise. But would you say that it would be possible for these guys over here who are too busy being active that they don't even care to play games? Or that this kid who does not exercise is because he spends too much time playing video games when he gets home? You don't think there is an association there? You would think, but I'm saying using that information. She's not looking at the charts. That's the problem. Yes, I'm asking you, do you see an association between the two? She doesn't, but for the rest of you, I want you to see it. Because if I give you those two graphs, I want you to make inferences. Meaning, well, what can you say about it? And what you could say is like, well, maybe that kid who does not exercise at all is because he spends too much time playing video games. Or that kid that doesn't play video games is just too busy doing other things. Those are the kind of things that they're going to ask you on the STAR test. And you should be able to look at the graph and say, that is possible. It is very possible. And you can probably cross the information the same way, saying maybe that is true. I'm not saying this is exactly true, but it is a possibility, yes. So, by the way, looking at this information, I can bring it to, you would say, to DISD's main people and say, this is our data. We have kids who barely exercise but play a lot of games. I think we should have more programs in our schools that encourage our kids to get more active. You could, but I think your parents would agree. I don't think I will find a parent that says, oh, I don't want my kid to be exercising. No, I can back this up by saying I have this study that says that a lot of our kids are obese, not just because of the food they eat, but because there's no exercise. Not necessarily for that. There's a lot of different factors from that. But I'm saying I can use this information and say, this is why our kids are playing too many games. Take all the games away. And if I show that to the parents, like, oh, yep, that's why. No more games for y'all. But you can use the data for both things. Yes. Do what? What do you think that is? Because they're overweight generally. A lot of people. I know why. They're very rare in situations when you're not overweight and you can't exercise. And I mean you cannot because of complications. But the majority of the time you run out of breath because you're overweight. And there is not I'm not saying this is a horrible thing. I'm saying this is the things that you guys should be paying attention to. What am I doing wrong? Am I eating too much junk food? Am I staying at home and watching novelas all the time? Let's get active. Let's get active. Don't worry about it. All right. So now that we have that, we can compare and look at the data in a different way. It's completely related to you, and you can say, okay, well, maybe this makes more sense now. Okay. Most of the data is less than 4 hours for exercise. We just agree with that, right? Most kids in this situation exercise less than 4 hours. That's true. We can see that. Most data says that most kids spend at least 6 hours playing video games, 6 or more. The median, basically for the exercise, it says 2.5. You can do that by eliminating. Yeah, right in the middle. And then the median for the other one is the same way. Dion, would you like to say something? No? Okay, good. Just making sure. Sure. We're not going to talk about. We don't have enough time, but I will next time. Yes. Yes. All these data is going to be on there, and we only covered it today. Of course you do. All right. So the range is basically the highest number and the lowest point subtracted. So you grab the biggest point, which is 12, and the smallest one, which is 0, subtract it, and you get 12 hours. But whenever you consider the guys that exercise too much, or, I mean, do it more than others, like these guys are called outliers because they're not part of the whole thing, right? So you will say 7 is the biggest one, right? Minus 12, minus 0, and you get 7 hours. And for the other one, be the same way. You have this guy over here who's way out there, right? Here's that one random kid with no video games. So you have 14 minus 0, and you will get it with the outlier. But without the outlier, without this guy, it would be 14 minus 6, and you get 8 hours as a range. You range. All right, let's go ahead and do this one on your own. I'll give you about 2 minutes. Tripping. Okay. So for this one, it's asking you for the median. The median is the easiest one to calculate, right? What do? Eliminate, right? Bam, 6. And then the range, you get the biggest number, which is 11, right? Minus the smaller one of 1, you get 10. Again, you are using the dots, not the lines, not the numbers. I'm pretty sure somebody grabbed this and that and subtracting them. There are no dots up here. That's some people's kids whose name I'm not going to mention. What? What? I didn't even say it was you. Look at her face like. So the range without the outlier, what do you think it would be? Without outlier. Do we have any outliers? That one and that one, right? So it will be, yes, it will be 8 minus 4. It gives me 4 for the range. That's not terribly difficult. For this one, we can see 2 different things going on. This is about running per week, the amount of miles you run per week. Why do you think we have this big cluster over here of people who run 12 to 14 miles per week? What? Track students, right? Students who are in track, they generally run a lot of miles per week. That's part of their programming. But the regular kids who are not in track, they're generally around here. You may run whenever you go to gym, you run a mile a day, or sometimes you don't run. That will work too. That works too. So it could be track or those kids who are in sports. And then you look at Class B. Class B is composed of regular, mainly average kids who, some of them run fast, like Lexini, I'm sure. So I send you all to the lab over there. She'll be running really, really fast. Whereas you have, like, let's say Soraya is like, oh, forget this. So she only does 2 labs. She'll be right here, whereas Lexi will be over here, right? Even though you're part of the same class, some of them are still running more. It's a frog. It's cute. All right, so whenever you look at the center of the plot, you will still do it the same way. Even though, hey, focus, focus. Well, otherwise we think about cats. No, not right now. When you're looking about the midpoint, you can still find it by eliminating. And even though they're separate, you will still get to 6. For this one, it'll be the same way. You still get 6. So you have the same center for both, even though the top one is really spread out into 2 clusters, and the other one is not. So the homework will be not this page, it'll be this page and the back. It doesn't look that horrible. Hang on. Hey, you're not paying attention. In addition, well, this is not a lot, trust me. They're throwing like 5 questions almost per side. In addition, I want 5 problems from IXL, and I will post the link in a minute. When